Hello, everyone. A very warm welcome to the Selenium Community Live event. Thank you so much for joining us for the event. A very warm welcome to our speaker today and a legend. Hey, Dorothy, how are you doing today?
Fine, thank you. Thanks for having. Thank you very
So,
much for
sir,
inviting me to do this. I'm looking forward to it.
First of all, Dot, it's an honor to host you, and thank you very much for accepting our invite. And on behalf of the project and the community, I extend my gratefulness to you and a very thank you for joining us today. Folks, Dorothy Graham, a name is enough, is a pioneering figure in software testing with close to over 50 years of experience spanning development, training, and consultancy. Dot, you started your career at Bell Labs, and then you went on founding Groove Consultants in 1989, and you went on building international reputation for quality training materials.
Mhm.
You have been a key architect of testing standards, and Dot helped establish ISEB and ISTQB qualifications, which many testers like you, like me, we qualified the exam. Dot, thank you for setting that for us. She has been an author and has co authored five influential books on testing, including Foundations of Software Testing. In the year 2012, Dot has been honored with the first ISTQB International Excellence Award. And in spite of multiple retirement attempts, she keeps her passion for advocating testing through consultation and conference speaking. So, Dot, thank you so much for joining us, and thank you everyone for joining the event. Over to you, Dot.
Well, thanks very much, and thanks again, Pallavi, for inviting me to this. I'm very pleased to be here and to hopefully share some ideas with you, which I hope you will find interesting and perhaps even informative. So this is what I'm planning to talk about. First of all, the origins of test automation. My first job was in test automation and what the tools were like years ago. Then where are we now with the survey and some thoughts about things I think people may have forgotten about good automation, and finishing with future directions and advice. So my first job was, as Pallavi's mentioned, at Bell Labs in Whippany, New Jersey, and this was from 1970 to 1972. I appreciate this is long before many of you were born, perhaps even before your parents or even grandparents were born, but never mind. I'm just old. So the job I had was working with a group that was writing software to interpret low-fargram signals. The low-fargrams were low-frequency um, um, sounds that were heard in the ocean. There were underwater microphones or hydrophones placed in various strategic points, and they could then pinpoint where particular sounds were coming from, particularly submarines. Now, this used to be top secret, but fortunately, I don't have to kill you after I tell you this now. And the computer we had to work on was a mainframe, of course, because there wasn't anything else yet back then. And it was a UNIVAC 1108. And this is what it looked like. Notice all those magnetic tape units. What was the computer like? It was 1.3 megahertz, half a megabyte of RAM, 100 megabytes of hard disk. What did it cost? Well, it cost $1.6 million in 1968. That's equivalent to nearly 15 million US dollars today. That's amazing, isn't it? What's in your pocket? Well, I've got a phone. Have you got a phone? What did it cost? What storage does it have? My iPhone has 12,000 times more storage and costs 20,000 times less. And that's only 55 years ago. What's going to happen in the next 50 years or so? I don't think any of us can imagine. So my job, I was hired as a programmer, although my degrees were in maths. And it was Fortran 5. I had no training in programming or anything like that, but I was put into the test group. In order to submit a job, you had to write the code out on coding forms, and they would then be punched onto punched cards with a punching machine that looked like this and was very, very noisy. One card was one line of code. So you have if your program was like 1,000 lines of code, you'd have 1,000 cards that you'd carry around in a box. Woe be to you if you dropped the box, by the way, because then they would get out of order. Things were a bit different back then. Also, when it came time to submit the job, you had to bring it down to the portal that led into where the mainframe was and leave it there, and then they would run the job when they got around to it. And then when your job had been run, they would, I don't know if they let us know whether they called us or whether we would just go down and see if it was ready. I think they let us know. And then we would get our results, a printout of what the program did when it ran. Woe be to you if you had a typo and it didn't even compile. That was it. That was your run, probably for the day. Submitting it and getting it back, that was called a turnaround. And normally you'd get maybe one turnaround a day. If you were lucky, you might get two. That is so different to the way things are now. But also it made it very important that you reviewed things very carefully. So my start in test automation was that my task at Bell Labs was to write programs to execute tests and to compare results. So I got into testing and test automation quite by accident. And I did a flow chart of my program, which was, I must admit, absolutely horrible. It was complete spaghetti. In fact, when I went back after I left, we had a holiday to Alaska. When I came back to see how people were getting on using the software that I'd spent 2 years writing, I found that no one had used it at all. So I think I wrote some of the world's first shelfware. My next jobs were at Ferranti in Manchester in the UK, and I was a developer in Coral 66 for police command and control systems. We used paper tape then, which again is really ancient nowadays. And I was interested in testing because I'd been in a test group. And in fact, one of the projects that I was on, it probably saved it from being a total disaster to just being merely very difficult. I then went to the National Computing Center and was involved in writing training courses. I had actually trained as a teacher, so getting into training with computing seemed like a good fit to me. Training courses in software engineering, and nobody really wanted to do a course in testing, but I thought, oh no, I want to do that. And they said, oh good, you can have it. And I thought, that's interesting. Maybe that's somewhere to specialize. And then as I became independent, when my children came along, I formed Grove Consultants because the house we lived in was called Grove House. So it sounded impressive. Now, what about the commercial tools? They first appeared back in the 80s. In fact, 1985 was the very first commercial software testing tool called Autotester, written by Linda Hayes and her brother Randy. She also wrote a little book about test automation, which is still actually quite interesting to have a look at today. But that was the first one, and then many more began to appear in the 80s. And in 1989, NCC asked me to write a couple of little booklets, one on just testing, verification, validation, and testing was what people tended to talk about back then, including reviews and inspection. And the tools, I had 25 of them in this first little booklet. Then after that, I wrote a more comprehensive tool report called the CAST report. Now, CAST stands for Computer Aided Software Testing. This is a much better name than test automation. Unfortunately, test automation has stuck. But back then, there were also CASE tools, computer-aided software engineering. Nobody called it development automation. There were tools to support project management. They didn't call it project management automation, but test automation seemed to stick. I wish it hadn't, but there we are. I think we're stuck with it now. I should tell you about when I was researching for the CAST report, I would go around various exhibitions, mainly of development tools, and I would ask them, well, what support does your tool provide for testing? And I got some interesting replies. Some of them had tools that did actually help, so I would put them in the report. One salesman, however, said to me, "Madam," that was a bad start, "if you use this tool, you don't need to do any testing." Honestly, that's what he said. Well, needless to say, we had a rather full and frank discussion at that point, and neither of us convinced the other. There were 4 editions of the CAST report, and by the way, that's why I put in something that's been quoted quite often about automated chaos just being faster chaos. The other editions of the CAST report I did in conjunction with Paul Hersick, and it wasn't an evaluation of the tools. It was just trying to factually report and objectively describe the features of the tools, looking at the tool vendor's material and taking out some of the excessive hype. There was one tool report. The US also had one that did an annual summary of the tools, and Ovum did one which was actually an evaluation done by Stephen Norman. But that was how you found out about tools back in the 90s. The internet wasn't there yet, folks. Now, the CAST report had 103 tools. Here they are. Do you recognize any of these? Are any of these still around? Well, a few are. I had a sort of a random check on some and found 3 that are still alive and well, it seems. Logiscope is one of them, but not many. So these are the tools that were popular back then, 30 years ago. What about the tools you're using now? I mean, obviously, I presume you're all using Selenium. And by the way, congratulations on it being around for over 20 years. That's really good. But will it still be around 20 years from now, 40 years from now? Maybe the software you're testing won't be around then, but people tend to assume the tools will be around forever, but they aren't. So it's worth remembering that at some point in your testing life, you may need to change to a different tool. So back then, how to find out about tools? Well, you could subscribe to journals, which would come in the post. You could get a tools guide, a printed one, buy one. You could get weekly computer magazines and look at the adverts for tools. You could go to an exhibition, even though they were mainly for development tools. You could telephone the tool vendors and read the printed blurbs they sent you about their tools. Maybe you'd find a user group, and you could go to a conference where there might be an exhibition of testing tools. But before 1993, they were only in the States. 93 was the first one that was in Europe, and that was the Eurostar conference. So how do you find out now about the tools? The internet, of course. Need I say more? Well, that involves a lot of things. There's social media as well, maybe artificial intelligence, training, attending a conference in person or online. There are so many ways to find out about tools. There's so much information available now. The problem isn't finding any, there's too much. How do you filter it? How do you know what's the really good stuff? Just because it's on the internet doesn't mean that it's good. So what were the tools like back then? Well, the tools worked really well for batch programming, but when graphical user interfaces came in the 90s, then the tools didn't work quite so well, especially capture replay. And yet the tool vendors seemed to sell them that capture replay was the way to go. It's like a video recorder. You just record your tests and play them back. Well, one of my favorite comments on that or analogies came from Stephen Norman, and he said, just imagine that you're going to record and play back your journey to work. So you get in the car, start it up, you press record. You reverse out of your driveway, don't go down to the end of the road and stop because the traffic light is red. When it turns green, you go on, and then a little bit later on, you make a right turn and turn into where. Now, the next day, you get in your car, you turn it on, and you press play. You reverse out of your drive, nearly being hit by a car that was coming that wasn't there yesterday, but he manages to avoid you, and you then go to the end of the road and stop, even though the light is green today, but it was red yesterday. So you take off and go when the light is turning red, and narrowly avoid getting hit as well. You get the picture. And testing is not something you watch. Testing is something you do. It's not passive, it's active. So record and play had, as a concept, had problems, especially when it was GUI. So the second chapter of our first book on test automation was why capture replay is not test automation. The reasons are, first, there's very much a mismatch of detail. If you said to a tester, go and test this setting up a car policy for a variety of people, they would go and they would do that. They would be able to think of what to test, how to test it. They might find some bugs. If you want to automate the tests for car policies, it has to have all the exact details. What policies they have to be on the file if you're updating them, what customer name, and so on. It all has to be there. The input data when you record a test is hard-coded into that script. And it's only inputs that are recorded. But that's not a test. That's an input. A test is, does it do what it should do, not just does it do. So you need to extend that by saying, well, what should it have done? And of course, the replayed test, just like the car journey, is tripped up by unexpected events, network outages, changes, and so on. Also, it's not just the individual test that you're running. There are other things that need to be done. You might have to set up things in the database for a set of tests. You might need to clear down. If something goes wrong, you might want to capture what's there, or you might want to clear it down and run the next test. And comparison, that's not a straightforward thing either. And there's no structure to the scripts. They're all just duplicates of manual tests, so there's lots of duplication. And this leads to high maintenance. It annoys me a bit that people say if you're testing GUIs, you're going to have high maintenance. That's not actually true, only if you test GUIs not very well. But more on that later. If you're going to get the best out of these tools, you need to have programming expertise and a more sophisticated approach. So I've written some books on automation, as Pallavi mentioned. Our first one was published in 1999. And part one was how to do automation well. We have talked about scripting techniques, comparison techniques, testware architecture, pre and post processing, maintainability metrics, lots of good stuff. People tell me it's still useful, even though the examples are a little bit long in the tooth, especially the case studies, which were part two. So we decided we'd like to update the case studies, and that turned into a book in its own right called Experiences of Test Automation. And we have 29 chapters. By the way, chapter 29 is available from Eurostar. You can read that one for free. And most of them are successes, but some are failures. And we sprinkled our comments throughout the book on tips and lessons learned, and this is a good thing to do. So that was that book. And then Saretta Gamba, who wrote one of the chapters in that book, when she got the whole of the book and read all the other chapters, she got very excited as a developer and said, these are patterns. And she wrote up the test automation patterns that she could see going through the book from her own experience and others. And she wanted to write a book, but because they were so interconnected, the patterns, it didn't work well as a book, but it does work very well as a wiki. And so we have written a book, and the book is how to use the wiki, basically. The patterns are now in a wiki, which is available free. It's called testautomationpatterns.org. And the story, the book here, the journey through the test automation patterns, is the story of Liz, a test automator, who lands her dream job. And she's really excited about it. But the book starts with her complaining to her former colleague about how it's all gone wrong in the first week. But fortunately, she gets told about the test automation patterns, and she uses them to solve all of her problems. Well, almost. So that's the 3 books I've done. So going into the 21st century, it's hard to believe we're 25 years into it already. But this was where everything changed. Obviously, the internet changed absolutely everything. We've gone from mainframes to PCs to Internet of Things, and now, of course, artificial intelligence and large language models. We have, from the tools, no longer point tools, but interconnected suites of tools, and they get more and more sophisticated all the time. The open source tools broke onto the market. 2004, I believe, was Selenium when you started. It's free, wonderful. There's support from the community. Yes, but it's still not magic. And the fact that you don't have to pay a purchase or a licensing cost for the tool doesn't mean it doesn't need investment. That's something that managers, I think, still don't understand. We had Agile, we have the continuous integration and delivery pipelines. Developers are doing testing. This is excellent. We have the cloud, we have smartphones. But unfortunately, we also have, with the growth of the automation tools, the view that all testers should write code, automation code. There's this prevailing view still out there. The only good tester is one who can code. I strenuously object to this and always have. A good tester is one who can test well. Now, I have no objections to people who want to both be testers and test automators, but those are two skills. One person can have more than one skill, obviously. But what I strenuously object to is the thought that testers who love testing, who perhaps aren't that keen on writing code, are denigrated. Their skills are not valued as much if they can't write code. I think that's wrong. And I hope that with the emphasis on artificial intelligence, maybe that's going to change. Maybe people will realize how important the critical thinking skills of a good tester are when applied to artificial intelligence. I hope so, anyway. So, where are we now? I gave a talk last year at the Automation Star conference in Vienna in October. And in preparation for that, I did a survey of where are we now in automation, which was very interesting to do. And you can see that, again, it's free to view. If you sign up, you get lots of free stuff from Eurostar if you sign up anyway. So I had 200 responses. I asked, what level are you automating at? 90% are at system level. That surprised me. 72% at API, 50% unit test. Obviously, people are doing testing at more than one level, which is good. 80% are using open source tools, but a third of them are using commercial and home-built tools. Again, more than one tool. Again, that surprised me that 80% are using open source tools. They're very popular. How long have you been automating? 20% less than 2 years, half of them for more than 5. I asked about training. What training have you had in the tool that you are using day to day? Well, a quarter of them had had more than 3 days training in the tool they're using, but a quarter had had none whatsoever. How can you be effective using something if you've never used it before without having any input from someone else who has developed expertise? What about training and testing? 70% had 3 days training and testing. Actually, what that tells me is the people who are doing the automation are probably testers. And how about training in automation architecture, how to do automation well? Well, 42% said they'd had more than 3 days in that, which is encouraging, although a quarter had none. How do you find out about automation? On the job, 80%. On the internet, 2/3. Events, printed material, using AI. I suspect AI is probably a lot higher now. This was taken about 6 months ago. And I had one open-ended question, and that was, what's the worst problem in automation? And I was expecting it to be something like flaky tests, high maintenance cost, but no. The most significant problem was management attitudes, unrealistic expectations. And that's very sad because we know a lot more about automation than we did 30 years ago, and yet that message doesn't seem to be getting through to managers. So here are a couple of questions from that survey, and I'd like you to have a think about what your own answer would be. If you had to change your automation platform, go to a different tool, for example, how much of the testware, the automated tests, the scripts and so on, all the stuff to do with the tests that are being run, how much of that would have to be changed? Is it less than 10% or more than 95%? In other words, you'd have to start again from scratch. Just have a think what your own answer is to this. Well, the survey came up with this. So changing less than 10% of the testware, that's excellent. They have a good automation architecture. They will be able to cope well with changes to the application. And if they had to change their tool, they would cope very well with that, preserving their investment in the automation itself, the tests. But 38% have a poor resilience to changing tool and probably also to changes in the application. Another question, how similar is the structure of the automated tests to the structure of the equivalent manual tests? Are they identical or similar, or mainly different or totally different to the manual tests? Again, what would your answer be? Here's what the survey found. Quite a few were fairly similar. A third were, but this is wrong. If your automated tests are too similar to the manual tests, then they are not well-structured automated tests. But 26% of them did have well-structured tests. So what do we mean by this? Well, if we have 100 manual tests, for example, we have 100 scripts. It's a one-to-one relationship. They would be identical. But one manual test should be 30 to 10 automated tests. And one automated script should be used by hundreds of tests. And if you have 1,000 manual tests, they might be implemented by only 50 scripts, together with data files and so on. So an automated test and a manual test are not the same. And this leads me on to some forgotten secrets of good automation, which the survey has highlighted, I think. So it may be that when the tools were very expensive, then people were more keen to justify investment in design to get the best out of them. But if the tools are free, they think they don't need to do investment. That could possibly be. Maybe we just start automating. That seems to be what the survey indicated. So my books and the test automation patterns have a lot of ways to do automation well. And I'm going to talk about three, which seem to me to perhaps be forgotten these days. First of all, what are the objectives for automation? And I love this quote from Melissa Tondi: automation makes testers more efficient, not less essential. I'm also going to look at abstraction levels and testware architecture, and then comparison design and test statuses. So what are your goals? Well, manual testing is slow, right? And automated testing is fast. So obviously that's going to be better. So let's go straight there, shall we? Well, hang on a minute. Yes, it's true that automated testing is more efficient once it's up and running, but what about how good are those tests? How effective are the tests? Efficiency can be improved with automation, but effectiveness is a characteristic of the tests themselves, whether they are run manually or automated. So if we have poor quality slow testing and we automate that, we have poor quality fast testing. And unfortunately, the worst place to be is down here, and a lot of people go straight there. So that's not a good thing to do, but unfortunately, it's common. And that's what you get if you don't think about how good are our tests. You will get much better results if you think, first of all, how can we improve our testing? That you're better off having better testing than automating testing. And then once you have your tests are good quality, are very effective, then you can think about automating them, but not automating all of them. Automating only the ones that give you the greatest benefit from automating them. This idea that we have to automate 100% of our tests, that's wrong. That's just not the thing to do. There are things that shouldn't be automated, but also if you're only automating the manual tests, you're missing some of the benefit that you can get from automation, from using the tools. So the goals for testing are not the same as the goals for automation. Goals for testing are to do with effectiveness, and for automation to do with efficiency. And we have a pattern called set clear goals in the wiki. Abstraction levels. Here are the testers, and here's the test execution tool that runs the scripts. And in between, we have the testware architecture. That's what I would describe it as. And ideally, we have structured testware. And the test automator is responsible for building it. And there are two levels of abstraction which are important. First of all, Down at the tool level, down at the detailed level, we want to make sure that the scripts are structured according to good programming principles. They want to be modular. They want to be, this is where you have scripts that are called by many other scripts. So one manual script is implemented by many scripts, which means that if something changes, you have to change only a few scripts rather than all of them or most of them. And if you have this abstraction level, it means your tests are easier to maintain and it'll be easier to change tools, so your automation will have a longer life. It will survive many changes to your system and also changes to the tools. Now, at the higher level, where the testers are interacting with the tools, if your testers are highly technical, then maybe they're happy to jump straight into code. But if they're not, and if you have testers who have good testing skills and don't want to write code, then they want to write tests in some kind of a domain-specific test language related to the domain they're testing. So if it's insurance policies, you might say write new policy. That would be a keyword. And if you have this abstraction level, it makes the test much easier to write because the keywords are interpreted, and there's lots of scripts here. So there's a lot to do for the automators. It means that the tests will be more people will be able to write tests, and the automation will be much more widely used by more people, by people who are non-technical, who often are the best testers. And we have a pattern called abstraction levels. Now, the test analyst and technical test analyst in ISTQB terms, looking at where these fit, the test analyst is the one who decides what tests should be run. The technical one, the automator, will convert this into low-level instructors and then hopefully into reusable modules in a script library. Then we want to go to data-driven, where the input data is taken out of the script, and then going on to the keyword-driven, where you have the test definitions in the language of the domain that's being tested. And the further you go along this progression, the easier maintenance becomes. Thanks to Mark Fuster for this slide. And we have a pattern called testware architecture. Now, comparison is something I think people often don't think very much about, but there are a number of choices. For example, are you going to compare while the test is running, or wait till it's finished and look at comparing, say, what's in the database? What about masks and filters for things you're not interested in? How often should you compare? Every fourth keystroke or every 10 minutes? Something in between, I suspect. And how much do you compare? And here I want to describe sensitive versus specific tests. So if we have our test outcome here, and the test is only supposed to check one field, if we have a test that only looks at that field, then that's a specific test. But if we have a test that looks at the whole of the screen, say, then that's verifying the whole of the outcome. Now, supposing we have an unexpected change down here, a bug. The specific test will not see it because it's not comparing down there, but the sensitive test will. So should all the tests be sensitive? Well, actually, there's a problem there. By the way, we have a pattern called comparison design. So if we have the unexpected change, which occurs on every test, perhaps it's a known bug that isn't going to get fixed anytime soon, but it's there on every test. So we have 3 fields that we're going to be checking in detail, so 3 tests for that. If all of the tests are specific, we don't see the unexpected change, of course. So obviously, all of the tests should be sensitive, right? Well, no, certainly one should be. But if they're all sensitive, then they all show the same change. So when you've seen one, you say, oh, yes, that's a known bug. That's not going to be fixed. When you see the next one, oh, yes, that's that same bug. The next one, yes. If you have 100 of those, it can be a bit tedious. Now, there is a way around it. By the way, I've got some bad news for you. A tool cannot judge pass or fail. A tool only does match or no match. If you think about it, the tool doesn't know what's right. The tool is only looking at what you say are the expected results. There's an assumption here that the expected results are correct. That assumption is more important in automation than it is in manual testing. If a tester is going through something and says, oh, I know the expected results say that, but I know that's wrong, no tool is going to say that. The tool is just going to say match or no match. Now, when a test fails, actually, it's not the test that fails, is it? It's the software that fails. We need to analyze that failure. So if it's a true failure, we write up a bug report. If it's a fault in the test, we fix the test. But what if it's a known bug? What if it's in 100 tests? Anything which fails, you have to investigate. So you investigate 100 tests, and every time it's the same known bug. This can eat a lot of time, and it's not efficient. It's not good automation. But there is a way around it. It's called expected fail status. And there are some others as well. And this is how it works. What do you compare to? If we compare to the true expected outcome, then we would say pass, because no differences were found to the correct outcome. Now, if differences are found, then we say fail, and we need to investigate. Now, if we get this pesky known bug, we can say expected fail. We define a different outcome to compare to, which has the known bug in it. So we can automatically compare, and it matches. This means it's failed in the way we expected, or it's a known bug. This means we don't need to spend any time analyzing these 100 tests, because the status of all of them was expected fail. It failed in the way. We don't want to call it pass, because then we'll forget about the fact that there is actually a bug there. Now, of course, if there are differences from the expected fail, then we don't know. And probably the first thing to do is to say, let's run it against the true expected outcome, because maybe they fixed the bug. And if you don't know or don't have anything to compare to, then also your status is unknown. And there are other possible statuses, like it's an environment problem, like blocking the tests, or setup problems, or a test needs to be changed and hasn't been done yet. So again, we have a pattern called expected fail. So those are some things that I think people perhaps are less aware of now than perhaps they have been perhaps when our book was first published. But they are all ways to get your automation working better. And there are others like test selector tags and other things. So looking to the future then. Of course, no talk would be complete without saying something about AI. So I'm going to say something about AI. And I think the Achilles heel for artificial intelligence is the training data. Dave Snowden, who's a great guy, I recommend everybody follow him. He says, we know more than we can say, and we can say more than we can write. But what's the AI trained on? Only on written data. It is restricted to what it's been trained on. There is other data that's out there that it doesn't know anything about, other written data even. But there's also other knowledge that it doesn't know anything about. Implicit knowledge, common sense, the things that we all know are sensible and the AI doesn't. This is why when you order an ice cream at McDonald's, it says, do you want bacon with that? Or at least apparently at some point it did. So this is a problem with AI. But there's also something else, and that is that the data set that it is trained on may well be polluted. If it's trained on the whole of the internet, for example, there's a tremendous amount of rubbish out there. So it's no wonder that it's getting crazy stuff. It's not really very good, not very good quality. It seems to be that it is very good at producing things that look plausible on the surface if you don't know much about it. And that's a danger. So is it hopeless? Well, no, actually, it's not, because AI can be very good at specific tasks. And when it has an unpolluted, narrow scope of the training data, it can do wonders, like discovering the protein folding or scanning radiology pictures. It's amazing how quickly it can do things that would take a long time for people to do otherwise. So it is a very powerful computing tool. And what about in testing and test automation. There's certainly a lot of people using it now and trying to use it and investigating it. But how do we know that what it's produced is actually correct? Who checks the AI itself? You wouldn't want the AI to tell you, oh, yeah, this AI is really good, would you? How are you going to tell what the AI is doing? Brijesh Deb says recently on LinkedIn, he says, AI does not remove the need for testers, it magnifies the need for thinking testers. Absolutely. I think this is a real opportunity for testers to show what they're capable of and how to hopefully make AI more useful for everybody. Now, just a comparison, because I remember back in the 90s when test automation was first coming around, and comparing that to what AI is like now. Oh, it'll solve all our testing problems. Yeah, it'll solve all our problems, right? It'll take our jobs. Yes, I seem to be hearing that these days. The managers think they don't need testers anymore. Managers think they don't need people anymore, right? The tools will do all the testing. AI can think, and AI can do all the testing and everything else, development as well. It could be good for tedious stuff, and AI can be good for some things. Eventually, the tools became useful, but they have limitations. And I believe eventually AI will become useful, but it will have limitations. And it does not replace humans, and AI will not replace humans. Humans are needed in order to evaluate the AI. So, my final advice to you, learn about AI. It's definitely here to stay. And use the techniques, the technology, and the tools wisely. Select where it's most useful. Learn about testware architecture, abstraction levels. Protect your investment in the automated tests. Although, interestingly, there was a talk given recently by Sean McGrill, who said he used a large language model to update the scripts that he'd used, and it did a good job of it. So maybe you don't have to have modular if you can get the language models to update them. So learn how to use them well. It's important to educate managers, co-workers, customers about what automation can do and what it cannot do. Unrealistic expectations and misconceptions are unfortunately still around. And it's up to us to hope to try to make them realize more accurately what automation can and cannot do. And the technology will change. The technology has changed unbelievably in the last 50 years. It's incredible to think how much that has changed, but people are still people. And I think people issues may well kill more automation efforts than technical issues. So all the best for you in your test automation journey. And I look forward to hearing if you have any questions. I can't hear you.
People's person. Okay. So Dot, thank you very much. It was a it was a wonderful session with some points made me laugh out loud. And I would like to really clap. It's an online event. We unfortunately I'm unable to see the fellow people who have joined us, but I'm very sure that we all feel like standing and clapping for you. So it was a wonderful talk, Dot. And it's unbelievable that some of the conversations which you have shared, which happened decades ago, are still relevant and very much happening around us. Some pretty much cool points. I really liked your anecdote which you shared with the salesman, that the tool is going to do testing, and and that what Steve Norman shared about the playback thing, the record and playback, everything was quite relatable. So we have some questions from the audience. and I would just ask you them. So we have a question from Ed. We have two questions. So the
Mhm.
first is the problem of management and unrealistic expectations something which we see across testing?
Yes, I think it probably is not only to do with test automation, but for testing as well. Managers may have the expectation that testing can test everything or testing can find all the bugs. So it's also a problem with testing as well. Yes, that's a good point. Thank you. That's a good observation.
Okay, Ed. Okay, Dot. So the second question by Ed is related to how does communication about automated testing is similar or different than communicating about testing in general?
Well, testing and automation have different objectives. Um, and uh, again, communicating with higher level managers is something that a lot of people find very difficult and find very challenging. Um, and it's important to get the message across, but it needs to be got across in a way which is going to be both non-threatening, if that's important for them, but also a way which is going to communicate the essential truths in a very concise way. Because the higher you go up the corporate ladder, the less time you have to spend on individual things because you're seeing the whole picture. So communicating needs to be very concise. I used to recommend if you ever get to talk about having an elevator talk, if you get in the elevator with your top level manager and you have like 2 minutes, what would you say? He might say, "Oh, what do you do here?" And you might well be flummoxed and hardly know what to say unless you've thought about this beforehand and you've actually got in your back pocket a 2 minute talk about what's important about what you do and what's important about what he does to help you do your job better. And you've rehearsed it regularly. If you do that, then you might well have a real opportunity to communicate with higher level managers in a way that you hadn't expected. Anyway, that's just an aside.
On that note, Lord, I also wanted to share an observation I've made. I've seen a lot of people across profiles, which I happen to see sometimes,
Mhm.
uh, is that they were basically quality engineers or they were quality managers, engineering manager, and then they have shifted to being an engineering manager or being a product manager. So I just wanted to ask you this question that do you think that someone who has a quality mindset becomes a better manager or is it a good career choice to proceed with further if you are a quality engineer, a quality engineering manager or an engineering manager is something which industry would also like to escalate people to and it would be good for them as well to see that as an option.
Yeah, I think it's a good thing if people in the higher levels of organizations do have a quality background because hopefully then they should understand more about it, how important it is, and how best to achieve it. But not everybody wants to move up and be a manager. Sometimes people are much happier just being at the technical level, playing about with the tools, or being really, really good testers. And a lot of times within organizations, the only way to increase your pay is to become a manager. And that
Right.
makes a lot of people unhappy because they don't want to be managers. They're better doing technical stuff. Some organizations have technical ladders that you can go up as well as management ladders. And I think that's always a very good thing. But I think having the more people we have with a quality background in the higher echelons, and anyone who's in quality now or quality engineering who wants to move up into management, I would say, yes, if that's what you'd like to do, I would very much encourage you to do that.
Okay, no, thank you. And now we have a question by Vipin. So he asks that what is the future of Selenium? And if he is looking for a job in the market, uh, what so basically there are a lot of tools which he has mentioned, Java, Selenium, TestNG, Cucumber, and he basically wants to understand that. So I will just rephrase his question is that I think it's a common mindset with people that will knowing more tools give you a better option at landing a job, or is it the skills or the domain knowledge which will help you better land the job?
Well, there's two things here. There's what you need to know to do a good job, and what do you need on your CV to get a job. And unfortunately, the things that filter the CVs are probably artificial intelligence, or at least computer programs that don't have any idea what doing a good job looks like because they're only looking at surface things. So if you have more tools that you know, it might get you past a filter that would give you an interview. But in order to do a good job well, if you know one tool, you know how you don't, the different tools are all doing similar things in different ways. But once you understand how a tool works and how to get the best out of a tool, how to structure the automation with whatever tool you've got, then you can do a good job with any tool. But again, recruiters don't seem to understand that in my experience or from what I've heard. So it's two different things. Good luck with finding the job, and maybe having more tools on your CV would help. I don't know.
Okay, thanks for that answer, Dot. I agree with you that knowing one tool would basically suffice you knowing other tools as well in the market. It is same with the programming language or in
Mm,
general. If your concepts are strong and if you have learned that along with any knowledge you are gaining, then you can just replicate it to other aspects. At the
exactly.
most,
Yeah, it's
the
just the
syntax would
same.
change.
I mean,
It's
the
the
tools
same,
are a programming language. If you know one
right?
programming language and know how to structure tests or structure code well, then you can probably write code in any language.
I also like the fact that you said that they're basically doing similar things. So that's a very important demarcation to know that they're doing similar things. Some comes integrated with batteries. For some, you have to use other plugins around and
Mhm.
make your framework.
Mm.
But having said that, we will move on to any other questions the audience have. A lot of people are thanking you for the talk, Dot. So thank you so much. And we have a question by Drina. Person asked that what is your answer to the survey's question? What is the worst problem around test automation and how to solve it?
Oh, unrealistic expectations. If I knew the answer to that, I would have solved it long ago. Um, it's I don't know whether it's like in education or the education of managers, people studying for like an MBA or something like that, that they don't really get realistic. Maybe more testers should get into trying to get good material into courses like that managers tend to take. But yeah, and communicating with your own manager and just trying to get the message through to them, it's difficult. And I wish I'd solved that problem, but I haven't.
Okay. Dot, would you like to have some water? If
Yeah,
you have been talking for a long time.
yeah,
So, on that note, I would think it would really help if we have managers in hierarchy in the job industry who have quality background. I think
yes.
that might help to
Mm,
solve some unrealistic expectations because they have been through the same boat. They might understand the problems better.
mhm.
So we have a next question from Ujjwal. Dot, do you have 5 more minutes so we can
Yes,
keep
yes.
going and take few more questions? Okay. So first of all, thank you for your question. If we have traditional testing going to heavily be impacted by AI, then which part of existing testing will continue to be in demand in future? Okay.
Mm. Um, well, I think because AI is able to do some of the tasks that are straightforward. I mean, the thing is what the automation tools did was they took over the things that were tedious to do. And in fact, the more tedious and boring something is to do, the more ripe it is for having a computer do it. And the AI are just sort of computers on steroids. And again, they can take over things that now are considered, they can do things which people can do, but the AI can do better, are the things which require less brain power, I think. Whereas the ability to take another view, to challenge things, to evaluate things, to say, hang on a minute, what's really happening, to investigate things, to go deeply into things, those are the things that people do. And those are the things that are very important to do with AI, and evaluating AI. I'm really pleased to see that AI hasn't been sort of accepted as, oh yes, it's going to solve everything. But there is a lot of pushback and a lot of things that I see on LinkedIn and things like that that are saying, well, hang on a minute, no, it's not what it said, how good as it says it is. There are problems with it, and I'm pleased to see that, and I think that's very healthy and is necessary.
That's well said, Dot. I think one aspect of traditional testing which will not get impacted is the power of thinking, being critical. That
Yeah.
is not going to get impacted at all by any tool or technology, whichever comes. I have another thought which I've been thinking about. You spoke about Dot having the kind of test automation solution where every every test case is mapped to a automation script, and you mentioned the complexities which arise for that, and you spoke about that driverless record playback
Mm.
with the Norman. So that brought me into an analogy where Tesla is building all that cars. So where if you set the destination, the car will take you without the need of the driver. So I think the better infrastructures will be built for such cars to basically take that route where there are no potholes, no sudden surprises which come. And like a robot, it can follow a streamlined path. But every analogy or every problem which we face may not be extrapolated to that. So
Mm.
there are tools and technologies in the market, but it really largely depends upon the kind of problem you are having
Mhm.
to take that solution. That would be something we can all think about. And we will just take a last question. Dot. Are there certifications which are good for testing role?
There is an ISTQB qualification for test automation. It's recently been updated and split into two. One of them aimed at management, which I think is very interesting and very good, and the other one aimed at the technical test analyst. In fact, Grove Software Testing, which I founded and still am in touch with and occasionally do things for, has just released the automation course as a course that they can run uh,
Okay.
online. So that's a qualification in automation, um, which is out there. I don't know the detail. I haven't sort of reviewed the syllabus in detail, but I'm knowing who was involved in writing it, which included Mark Fuster and other people who I know pretty well. I'm sure it's really good, and what I've seen of it is.
Okay. So, so I think we have answered and taken most of the questions by the people. So I would like to thank you all for joining us today. And thank you so much, Dot. Is there something you would like to share with the audience? You said you had a question. You would like to put it in the end. Would you like to do that, Dot?
Well, there's one thought. I have some additional slides in my pack.
Sure,
Um,
Dot.
one of the things that seems to be very popular is a lot of people talk about coverage, and I think coverage is something of an illusion because if you look at if we have in this illustration major bugs and minor bugs, the breadth of coverage, that's what the breadth of testing, that's what coverage is. It's a width approach, not we're going wide and not deep. So that's what you're looking at. And yeah, it's effective. It found a couple of bugs. But lumpy testing or depth testing is more selective. It might have some at the high level, but it's also going to delve deeply into some parts of the software. So, which is more effective? Which is better testing? Well, if you look at the number of bugs found, going deep is probably better. But what happens is you say, oh, I've covered everything, so I've tested everything and I haven't missed anything. And this is an illusion. No amount of coverage covers everything, no amount of testing finds everything, but you need to get a mixture of the wide testing and the deep testing in order to do the best.
That's awesome.
Don't know if that's useful, but
It was, Dot. It was. Okay, Dot. So I will, should I remove the slide deck, Dot?
yeah. Mhm.
Okay. Okay, Don. Yeah, that was a very insightful point, and I think it basically also stresses on the point that any testing activity cannot cover all the that your software will be bug free, or
Mm,
that just doesn't happen. So
yeah.
we need to understand that aspect. Okay, Dot. So I would like to thank you very much for your time and
Thank
for this wonderful session. It was extremely insightful, and your experience, and there are a lot of points to ponder on. I'm sure everybody can go back and have a reality check as to where we are all right now heading as an industry altogether.
And I'm
And we
happy
thank
to,
you, Dot.
if anyone wants to email me or contact me on LinkedIn, I'm happy to continue discussions. So thank you again for inviting me, and hope it's been useful. Thank you.
Thank you, Dot. Thank you so much. Bye, Dot. Take care. So thank you everyone for joining the community event. With this session, we culminate the season one of Selenium Community Live. We would like to thank all the speakers who joined us across all these past 8 episodes, which started with celebrating 2 decades of Selenium in the industry. And as we all in the background prepare for the next season, do keep in touch, and please subscribe to the Selenium YouTube community event and remain in touch. Thank you, everyone. Thank you for joining, folks. Bye.